and basically it came from IP chains, but IP tables is an improvement with a lot of added new features, although it does implement chains. And I'll need root privileges because it depends on the flavor of Linux you're in. If you're in Fedora and you're logged in as root or using SU, you wouldn't need to do this. But in Ubuntu, you'll need sudo IP tables, and I'm going to use the -L switch. This will just kind of illustrate there's three built-in chains, right? The built-in chains are input, forward, and output. Now, you can also create user-defined chains, so you're not limited to these three, but these are the three built-in. And the input chain controls packets coming into the PC, so it's pretty straightforward. It explains itself. The forward chain controls packets going through the PC, implementing the firewall. And that's just, if this were a multi-home computer, in other words, if I had more than one network card, such that we were routing packets and traffic between multiple subnets, then we would make use of this chain frequently, the forward chain. So inputs coming in, forwards going through from one network interface to another on a multi-home system. And finally, you have output, which are packets that are leaving out of the PC. And these are the three default built-in chains. Now, rules can be added. We can append rules and set default rules for each one of these chains. And they all work in succession and can combine together. Common useful IP tables command options. There are basically several default commands that we might implement, very common ones. And the first one we already did, IP tables -L, which will list any rules that you have applied. And let's look at some of the other options. F will flush out any rules that I had. I don't have any rules yet, but if I did, that would have flushed them out. If I wanted to delete a rule, I could specify a rule number. Now, again, I don't have any rules, but it would be IP tables with the -D option to delete a rule. If I used the P option, that would specify a default policy on one of my chains, input, forward, or output. And if I use the -A option, that would append a rule or add a rule to one of my built-in chains or a user-defined chain. So just looking at some of those command line options there. Let's test services using protocols HTTP, FTP, SSH, and Telnet without any rules applied to IP tables. In other words, we will verify that they function with the firewall disabled. So we're on Pegasus right now, and I have four commonly used server services going. So 4 daemons are set up. There's the Apache 2 web server, and remember that uses port 80. There's VSFTPD, the Very Secure File Transfer Protocol daemon, or FTP, which uses ports 20 and 21. There is Telnet, or NetD, which uses port 23, and I have Secure Shell, which uses port 22. So we're going to look at configuring rules in IP tables to allow and block packets traveling and utilizing these ports on both incoming and outgoing. So the very first thing I want to do, I'm on the server. Let's hop on a client real quick. We're on the server Pegasus. We'll go to a client called Galactica, and we'll test these services before we actually do anything. So right now, this is sort of the default. There are no rules in my firewall. So IP tables list, no rules applied here. So let's test the services and verify that we can connect before we start configuring and adding and removing things from our firewall. We will log off the server Pegasus and log on to the client Galactica. Okay, we're on our client, the Galactica, and let's go test these services on our server before we start locking things down and manipulating rules in our chains for IP tables. So the first thing, let's verify our test is let's do FTP. So I'm going to FTP and the IP address, that's the IP of the Pegasus. Alright, so I got the banner. Of course, for doing banner grabbing, that wouldn't be so great, but in this case, just to illustrate, and I've enabled anonymous login, so I'm going to go ahead and just log in anonymously. So everything's okay there. There are no rules blocking us, firewalls letting us through with FTP. Let's try Secure Shell. And I'm just going to do 199.207.13.13, which is Pegasus' IP address. And let me go ahead and hop in here and okay. And it looks like Secure Shell has no problem. It's not being blocked over port 22. So we verified FTP over ports 20 and 21. We verified Secure Shell over port 22. Let's do Telnet. Not a very secure protocol because it uses plain text for the authentication process. Secure Shell would be better because it's encrypted, but just for the purpose of testing it, we'll go ahead and use or make use of that service. And okay. And all right, so it's letting us through. Looks like we can make the connection there. So we've checked FTP, we've checked SSH, we've checked Telnet. Let's check HTTP. Remember that works over port 80. If it's normal web traffic, if it's SSL or secure traffic, it's port 443. And I just want to go and same thing, 199.207.13.13. I'm just going to go to Pegasus. All right, and I'm able to load and display my web page, no problem. So we verified that all of these server services work from the client Galactica in terms of accessing it from the server Pegasus. Now let's go configure some rules on our firewall, and we'll come back and test connectivity and see how implementing and configuring and changing different rules with IP tables changes the ability to access, access services across the network from our servers. We will log back onto the server Pegasus and configure a single catch-all rule. Alright, we're back on the server, the Pegasus now. And again, as of right now, if I list it, there are no rules applied. I need to know the interface because, especially if it's a multi-home computer with more than one network card or interface, I need to know which NIC packets are coming in from, and if I want to route them through, which NIC I want to, port I want to send them out of. But in this case, what I'm interested in, this is I only have one NIC interface configured, and it's labeled as, or enumerated as ETH2. And that's important if I use the -I option to specify an interface. Okay, so again, I'll list the default chains here, input, forward, and output. There are no user-defined chains at this point. So nothing's blocking or processing traffic in any way. It's just it's a free-for-all at this point. Typically, what you'll do in IP tables is you'll apply your rules to one of the built-in chains or a user-defined chain, allowing or blocking certain kinds of traffic, and then at the end of that, you'll add what's called a catch-all, where you pretty much just drop all packets that do not comply with or do not apply to any of the previous rules that you'd listed before. Now, you'd never want to put the catch-all above other rules, because you always want it to be the last rule applied, such that legal traffic or traffic that you want would be allowed through, and then the catch-all would only drop or block traffic that you don't want. But we're going to deviate from that just for right now because we don't have any rules, and since it's the catch-all is probably one of the more one of the simpler rules we could add to IP tables. So let's go ahead and add that, and just look at the behavior. We'll hop on over to the the client, and we'll try to access these server services, these daemons and things on Pegasus from Galactica, and see how see how these rules in our input chain affect the services we're able to access from the server. So I'm just going to add pretty much a catch-all. I'm going to do sudo iptables, and the options I'm going to use, A, to append a rule. The next one is the chain label, in this case the built-in input chain. I'm going to use -J to specify an action, and I'm going to drop the packets that conform to -P, the protocol. So I'm going to use TCP, Transmission Control Protocol. Remember, there's UDP, User Datagram Protocol, and TCP, Transmission Control Protocol. And I'm going to specify the interface, and in this case it's going to be ETH2. Remember when I did ifconfig, that was my interface. And if I did that, remember, I can list it, iptables-L. Let's see what that role looks like now. And so if I look, there's still nothing on my output chain, still nothing on my forward chain, but on my input chain, notice that I have the target, the protocol, the option, the source, and the destination. So in this case, I'm going to drop transmission control protocol. No real, no real option specified. So this is for anybody, from anywhere to anywhere. So this is kind of blocking everything. So let's verify that. We'll check those 4 services on the client real quick, and we should not, with this rule applied, be able to access anything. Let's log on to the client Galactica and test that our rule blocks all transmission control protocol traffic. So now I'm on the host, and let's check our services. I'm going to do HTTP first. And again, with that sort of catch-all applied, it should just block everything. Not very useful, but it can at least kind of maybe illustrate the way the rules work, sort of the purpose. So, yeah, I mean, I'm connecting, I'm trying, server's there, it's online, it's got an IP and everything, I have connectivity, but the firewall is completely blocking my HTTP access over port 80. So it's doing, what I would expect it to do. The next service, let's try FTP. So I'm going to try FTP in 192.168.13.13. And again, I have connectivity, but when the Galactica tries to connect to the Pegasus, the firewall is blocking the connection there. In this case, I'm over ports 20 and 21. Okay, so the next one, let's try the better version of remote access, which would be Secure Shell, the encrypted version, and SSH 192.168.13.13. And again, the firewalls, those packets are coming in, but regardless of the port, if it's Transmission Control Protocol, TCP, it's just dropping the packets, not allowing the connection in. And finally, let's try to Telnet.